Hello friends, this video series is based on requests from our viewers. We will be discussing all the geometry formulae from class 10th. So in this video, we will start with all the formulae from the Similarity chapter. So let's start. The first formula is about ratio of areas of two triangles. So here are two triangles. They are not similar or congruent, but they have the same height h. And the bases are different. See B1 and B2. Then what will be the ratio of the areas of these two triangles? Well, for triangle ABC, the area will be half into base, which is B1, times height h. For PQR, it will be half into B2 into h. Now friends, h gets cancelled, half gets cancelled. So you will be left with B1 by B2. So we can say that the ratio of the areas of two triangles having the same height will always be B1 by B2. That is the ratio of their respective bases. On the same lines, if you have two triangles having the same base but the heights are different, then what will be the ratio of the areas of the two triangles? Friends, remember ratio means simply dividing. Okay, so the area of triangle ABC here will be half into base, which is B, height is h1, and PQR will be half into base, again B, into height will be h2. So here the base gets cancelled and half also. So you'll be left with h1 by h2. So the ratio of the areas of two triangles having the same base will be h1 by h2, or the ratio of the respective heights. Friends, now we come to the basic proportionality theorem. So in this theorem, you have a triangle ABC and this line segment PQ is parallel to BC. So PQ is parallel to BC. Then it also divides the remaining two sides. Now, which are the remaining two sides? AB and AC. So PQ divides AB and AC in the same proportion, and that's why it's called the basic proportionality theorem. So what do we mean by dividing it in the same proportion? It means AP by PB is equal to AQ by QC. This is what it means by dividing the remaining two sides in the same proportion. So this is the basic proportionality theorem, or the BPT. Now we have the converse of BPT. Now what do we mean by converse? Converse means the other way round. So suppose it is given to us that this line segment PQ divides AB and AC in the same proportion. That is, it is given to us that AP by PB is equal to AQ by QC. This is given to us. Then the converse of BPT states that the line segment PQ has to be parallel to BC. So this is the converse of BPT. The next theorem is the angle bisector theorem. So here you have a segment AE which bisects this angle A. So it is given to us that AE bisects angle A. Then according to this theorem, the bisector AE divides the side opposite to this angle, which is the side BC. So it divides BC in the ratio of the remaining two sides, that is AB and AC. So what we mean to say is that BE upon EC is equal to AB upon AC. So this bisector divides the opposite side in the ratio of the remaining two sides. Because we are talking about the bisector of an angle, this theorem is known as angle bisector theorem. Now the converse of the angle bisector theorem states that if you have a point E on this side BC such that BE upon EC is equal to AB upon AC. Just have a look, friends. BE upon AC is equal to the ratio of the other two sides. If this is given to us, then the converse of this theorem states that this segment AE actually bisects angle A. That is, AE bisects angle A. So this is the other way round of the angle bisector theorem, that is the converse. Now friends, coming to this theorem, we have three parallel lines L, M and N which are passing through two different transversals T1 and T2, then the ratio in which these parallel lines divide the first transversal is the same as the ratio in which they divide the second transversal, which means AB upon BC is equal to PQ upon QR. This is the property relating the three parallel lines and the transversals. Friends, now we come to the test of similarity of triangles. There are three tests here. The first one is the AA or the AAA test. Suppose you have two triangles ABC and PQR such that angle A is equal to angle P, or you can even say angle A is congruent to angle P. Angle B is congruent to angle Q, and angle C is congruent to angle R. So if you have this type of scenario, then we can safely say that triangle ABC is similar to triangle. Now A is equal to P, so it will be here. B is corresponding to Q and C is corresponding to R. So triangle ABC is similar to triangle PQR. The reason is the AA or the AAA test. Okay, so this is the first test, friends. Now the second test is the SSS test. So in this test, friends, again we have two triangles, say PQR and ABC, such that the ratio of PQ and AB. So just have a look, friends. We are dividing PQ by AB and we find that it is equal to the ratio of PR and BC, which is equal to the ratio of QR and AC. So what do we see here? The corresponding sides are proportional to each other. They need not be equal, friends. They just have to be proportional to each other. Then we can say that triangle PQR is similar to triangle BAC. Please note, friends, that they have to be corresponding. So this order is very important. So this is the SSS test. The third test is the SAS test. So again we have two triangles ABC and XYZ where you have two pairs of corresponding sides proportional. So suppose you have AB upon XY is equal to BC upon YZ. So here you have these two pairs proportional to each other, and the angle between them, friends. What is the angle between AB and BC? It's angle B. And what is the angle between XY and YZ? Yes, it's angle Y. So the angle between these two sides should be equal or congruent. Then in that case, triangle ABC will be similar to triangle XYZ by the SAS test. Now friends, there are three very simple properties of similarity of triangles. So the first property is that if I take any triangle, say the same triangle ABC, can I say that this triangle ABC is similar to itself? Yes, definitely I can say that a triangle is always similar to itself. So this property is known as the reflexivity property. The next property is that if I have two triangles, say triangle ABC, which is similar to triangle over here, it's XYZ, then if this is the case, then I can say that triangle XYZ is also similar to triangle ABC. So if ABC is similar to XYZ, definitely XYZ will also be similar to ABC. So friends, this property is known as the symmetry property. And the last property is that if I have three triangles such that if my triangle ABC is similar to triangle XYZ and triangle XYZ is in turn similar to say another triangle PQR, then I can safely say that triangle ABC has to be similar to triangle PQR, friends. So this is known as the transitive property. What is it called? The transitive property of similarity of triangles. Friends, now we come to the theorem of areas of similar triangles. So if we have two triangles ABC and PQR which are similar to each other, then if we take the area of triangle ABC divided by the area of triangle PQR. That is, we are taking the ratio of the areas of two similar triangles. Then it is always equal to the ratio of squares of their corresponding sides. So friends, what are the corresponding sides over here? Looking at the order, AB is corresponding to PQ. So AB upon PQ, but I need to square it. Okay. And what is the next pair of corresponding sides? Yes, BC square by QR square. Right? Like this. And the next pair will be AC square divided by PR square. So friends, this is the formula connecting the areas of triangles with squares of the corresponding sides. So friends, I hope that you found the video useful. If so, please do like and share the video. Do leave your comments in the comment section below and consider subscribing to Enjoy Math. In the next video, we will be discussing all formulae from Pythagoras theorem chapter. So till we meet again, take care.